Morning, everybody. Today we're going to talk about the area of a region between two curves. Okay, this is a topic that's almost guaranteed to be on the AP test, so make sure you pay close attention here today. So, with small modifications, you can extend the application of definite integrals from the area under a curve to the area of a region between two curves. So let's say we have two functions that are continuous on the interval AB, and the graphs of both f and g lie above the x-axis. Then the graph of g lies below the graph of f. You can geometrically interpret the area of the region between the graphs as the area of the region under the graph of g subtracted from the area of the region under the graph of f. Okay, so like I said, this is guaranteed to be on the AP test. So what does this look like? If f and g are continuous on the interval a to b, and g of x is less than or equal to f of x for all the x's in the interval ab, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is, the area is the integral from a to b of f of x minus g of x dx. All right, so let's take a look at what this would look like in real life here. So we've got a function, we've got the area of a region bounded by the graph of, here, we'll make this one red, y equals x squared plus 2, so that would be this one right here. And the graph y equals negative x, which would be this graph right here. Okay, and we want the area between those between 0 and 1. So we want the shaded region here. Okay, so all we're going to do is we're going to take the integral from 0 to 1 of x squared plus 2 minus negative x dx. Okay, so these two negatives cancel out, and this becomes x squared plus 2 plus x, which we're going to go ahead and rewrite it as x squared plus x plus 2 dx. Okay, now we integrate this. This is super easy to integrate. It's going to be 1/3 x cubed plus 1/2 x squared plus 2x. Evaluated from 0 to 1. So then we're going to go ahead and plug in 1. So this is going to be 1/3 times 1 cubed plus 1/2 times 1 squared plus 2 times 1 minus, and then we're going to plug 0 in here, but these are all going to be 0 then, so this is just going to be minus 0. So this is 1/3 plus 1/2 plus 2. So what is this? This is 2/6 and 3/6 plus 2. So this is 2 and 5/6, which is going to be, a better answer would be 17/6. And that's the area of that yellow shaded region right there, 17/6. Okay, so not real difficult to do there. Let's look at this one. Find the area of the region bounded by the graphs of f of x equals 2 minus x squared. That would be this red curve right here. And g of x equals x, which is the blue line. So I tell you what, this is not real hard to do. You had an example very similar to this. Go ahead and put this on pause. And then figure this out for yourself, and then jump back on here and compare it to what we get. So pause your video now. Okay, so here's what we would do. We would take the integral. We're going to go from -2 to 1. And we're going to take 2 minus x squared minus x dx. All right, so that's, if we clean this up a little bit, it's going to be the integral from -2 to 1. Of, let's go ahead and rewrite it as negative x squared minus x plus 2 dx. Now we integrate, so this is going to be negative 1/3 x cubed. This is going to be negative 1/2 x squared. And 2x, and we're going to evaluate that from negative 2 to 1. So we'll go ahead and plug 1 in here. So this will be negative 1/3 times 1 cubed minus 1/2 times 1 squared plus 2 times 1 minus negative 1/3 times negative 2 cubed minus 1/2 times negative 2 squared plus 2 times negative 2. Okay, so again, this is negative 1/3, negative 1/2 plus 2. And then we're going to subtract. Okay, so this is going to be negative 8 times negative 1/3 is going to be positive 8/3. It's going to be 4 times negative 1/2 is going to be negative 2. And then minus 4. Okay, so this is going to be what? This is going to be negative 5/6 here. So this is going to be 1 1/6, which we'll probably write as 7/6. And then over here, let's see, this is going to be what, 2 2/3 right here. Minus 2 would be 2/3, minus 4 would be negative 3 1/3, which would be 10/3. Okay, and then if we get a common denominator, this is 7/6 minus 20. Oops, this should be plus because the negatives cancel out. So this is 26. So this is 27/6. Okay, which is going to be what? 4 and yeah. All right, let's check our answer here and make sure that we did all the arithmetic right. And yes, it's 4 1/2. So there you go. Got the area between those two curves. All right, so the sine and cosine curves intersect infinitely many times, bounding regions of equal areas. Find the area of one of those regions. So here we got the sine curve in red, we got the cosine curve in green. They intersect here and here at those two blue points. We want to find the area of that shaded region between them. Okay, so the first thing we need to figure out is what is that point and that point. So we need to know when the sine of x is equal to the cosine of x. Okay, so let's see. If I divide both sides by cosine, I get sine x over cosine x would equal 1. So the tangent of x, when is the tangent of x equal to 1? And that's going to be at pi over 4 and 5 pi over 4. Okay, so this is going to be pi over 4 right here. This is going to be 5 pi over 4 right there. So we'll move this over here a little bit. All right. Now we can go ahead and integrate here. So we're going to integrate from pi over 4 to 5 pi over 4. And let's see, sine's bigger, so it's going to be sine x minus cosine x dx. All right, so we'll go ahead and let's see. The integral of sine is let's see, that's going to be negative cosine. And the integral of negative cosine is going to be negative sine. And we're going to evaluate that from pi over 4 to 5 pi over 4. So this would be negative cosine of 5 pi over 4 minus the sine of 5 pi over 4 minus negative cosine of pi over 4. Whoops, 5 pi over 4. Sorry. No, pi over 4. Minus the sine of pi over 4. Okay. Hang on here real quick. Okay. So, sorry for that pause. So let's see. This is going to be the cosine, negative cosine of 5 pi over 4 is going to be negative square root of 2 over 2. Minus the sine of 5 pi over 4 is also going to be the negative square root of 2 over 2. The cosine of pi over 4 is going to be square root of 2 over 2. And then the sine of pi over 4 is also going to be square root of 2 over 2. So, these cancel, those cancel, and I get 2 square root of 2 over 2. And this is minus negative 2 square root of 2 over 2. Of course, those cancel out. We get to cancel those. And we just get square root of 2 plus square root of 2, which is 2 square root of 2, which is our answer. So that's the area between the sine and the cosine curve on any interval. Okay, example 4. Find the area of the region between the graphs of f of x is 3x cubed minus x squared minus 10x, and g of x is negative x squared plus 2x. Okay, so you'll notice if you look at the graphs here, here's your x cubed, here's your x squared. So to find the area between those curves, we have to do a couple things. We have to find out where they intersect. And then we have to integrate it in two different pieces, because the cubic is bigger than the square here, but the square is bigger than the cubic here. Okay, so the first thing we got to do is find out when those things are equal. So we'll take 3x cubed minus x squared minus 10x, set it equal to negative x squared plus 2x, and we'll move this all over here. So this is going to be 3x cubed. The x squareds cancel out, and minus 12x equals 0. I can factor out the 3. Oh, and an x. Factor out 3 and an x. So that's going to be x squared minus 4. And then this will factor into x minus 2, x plus 2. So I got 3 zeros. I got a 0 at 0 for this one. I've got a 0 at 2 for this one. And I've got a 0 at negative 2 for that one. Okay. Now let's go figure out what integrals we're going to use here. Okay. So we're going to take the integral from negative 2 to 0. All right, so we'll take the integral from negative 2 to 0. And we want the cubic coming first here. So this is going to be 3x cubed minus x squared minus 10x minus negative x squared plus 2x dx. And then we're going to add to that the integral from 0 to 2. We're going to switch these around now. And I don't look like I'm going to have enough room here, so let's take this, write it down here, plus the integral from 0 to 2 of negative x squared plus 2x minus 3x cubed minus x squared minus 10x dx. Okay. So now we got to do a little bit of algebra here. So integral from negative 2 to 0. Let's do this, plus, plus, minus. So we've got 3x cubed. The x squareds cancel, and I get a minus 12x dx. So that's a little simpler. I'm going to add to that the integral from 0 to 2. Okay, we'll make that plus, minus, plus, plus. So we've got minus 3x cubed. The x squareds go away again, and we get plus 12x dx. And now we just have to integrate. Okay, so this is going to be oops, 3/4 out here in front. Minus 6x squared. Evaluated from negative 2 to 0. Can add to that. So this is going to be x to the 4th. And this is going to be 3/4, but it's going to be negative. Okay, and then we've got plus 6x squared. And we're going to evaluate that from 0 to 2. And then, let's see, what do we have here? So if we plug in 0 in both of these, it's going to be 0. So it's 0 minus 3/4 of negative 2 to the 4th minus 6 times negative 2 squared. Plus, over here, negative 3/4 2 to the 4th plus 6 times 2 squared. And then if I plug in 0 to subtract that, that's just going to be 0 again. So I don't have much to do there. And now I just got to figure out what this is. So let's see here. This is going to be 4, negative 24 here. And let's see, 2 to the 4th power, negative 2 to the 4th power is 16. Divided by 4 is 4, times 3 is 12. Don't forget your negative sign. And then this is going to be 16 divided by 4 is 4 times, that's going to be negative 12 right there. And this is going to be plus 24. Okay, so this is negative 12, but it's positive, so this ends up being 12 plus 12, which comes out to be a nice 24. And let's check our answer, see how we did. The answer is 24. Woohoo! Okay, so the area between the two curves is 24. It looks like the area here is 12, the area there is 12. So, okay. Moving right along. All right, now we got kind of a weird one because we've got x in terms of y here. So find the area of the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. Now, I would do myself a favor and graph these. Okay. Not a bad idea to do. And then remember, we're going to be integrating this way. So we're going to take the red curve, which is the 3 minus y squared, and we're going to subtract the green curve, which is y plus 1. Now, okay, so this is going to be, now you got to kind of think sideways here. So it's going to be the integral from -2 to, oh, we got to figure out where they intersect each other. So we should start with that first. So set these two things equal to each other. 3 minus y squared is equal to y plus 1. We'll go ahead and move this all over here so we get y squared plus y minus 2 equals 0. And we can factor this. And then y is going to be 1 and y is going to be -2. Okay, so we're going to be integrating from -2 to 1. So we're going to integrate from -2 to 1. We're going to take 3 minus y squared, and we're going to subtract y plus 1. This is dy this time. Okay, so let's clean this up inside here. So this is going to be negative y squared minus y. That's going to be a -1 plus 3 is going to be plus 2 dy. And now we can integrate that. So this is going to be -1/3 y cubed minus 1/2 y squared plus 2y. These numbers should look familiar. And then we're going to evaluate from -2 to 1. So we're going to go ahead and plug in 1. So this is going to be -1/3 times 1 cubed minus 1/2 times 1 squared plus 2 times 1 minus -1/3 times -2 cubed minus 1/2 times -2 squared plus 2 times -2. And now it's just simply algebra, right? Or it's just not even algebra, it's just arithmetic. So this is -1/3 minus 1/2 plus 2, which comes out to be 1 and 1/6, or 7/6. Minus. Okay, this is -8, that's +8/3. This is 4 times, that's going to be -2, and -4. Okay, so again, this is 2 2/3. -2 is going to be 2/3. -4 is going to be -3 1/3. Which these two negatives are going to cancel out. This is going to be plus. This is going to be 10/3. Okay, we change this back to sixths. 26th, so this is going to be 27/6. Which, let's see, if we divide that both by 3, that's going to be 9/2 over 4.5. Okay, and there you got the right answer, 4.5. Okay, and here's your assignment. Short lesson today. You're going to do 1 through 11 odd, 17 through 33 odd, 39, 47, and 55. So good luck, and I'll see you next time.